Guys, come on. I don't have that much material. Let's make sure we can just get through this, okay? The graph of y equals 3 cosine x is translated up 3 and left pi. So what I'd like you to do is be able to write it out in terms of a, b's, and h's, and k's. They're giving you this translation. So what we're going to do is change this parent function into a shifted function. Now, the textbook a lot of times just uses, hey, you're moving left or right. In a minute here, I'm going to talk about something called a phase shift. Phase shift is the more technical language for it. It'll say it has a phase shift of negative pi. Something like along those lines. So here, if you're moving up, are you moving horizontal or vertical? So what is your k value? 3. Positive 3. Left pi. Is left pi positive or negative?
Negative. Positive. Because, or no, negative. Yeah, positive. Because there's leftover pi, and that's great. Wait, no, it's positive.
You're moving left. Is left in the number line positive or negative? And now when you put it together, it becomes minus the negative. That's where you're going. So your final answer would be y equals 3 cosine x and a partridge.
Do you have to have the parentheses?
Yes. You have to have parentheses because your h values will always be grouped. H values are always grouped. If there's no parentheses, it means there's no h. Okay? Yes, sir?
Would that be x minus 3?
We went up. We went up 3. So up is your vertical. Up and down, oops, vertically. Left and right are your h's. Okay? Yes, ma'am.
So let's say like pi was 2 and it didn't have any parentheses.
I can't hear you.
So let's say pi was 2 and there was no parentheses. Would that just mean that it'd be like 3 cosine x plus 5? Because that would just be like k, and you have to combine like the like terms.
If there was no parentheses.
And pi was 2.
Oh, pi was 2 and there was no parentheses.
Yes.
Yes, then your vertical would be up 5.
Okay.
That's all. H values are always grouped in H, or always grouped in parentheses. You know it. You guys are getting married already? You're not even. You don't have a driver's license. The graph of y equals 5 tangent 4x is translated left, pi over 4, and then is reflected over the x-axis. So you're again, you're moving to the left, which means your h value is going to be negative pi over 4. But when you start thinking about this whole translation, when things are translated over an x-axis, it means they flip-flop. Now, is the x-axis the vertical or the horizontal? It's the vertical. Oh, I'm sorry, reflected. It's reflected. I'm having one of those moments. I'm getting old. So your x-axis is the horizontal, and if you reflect something over an x-axis, it flips. What does a positive tangent graph do? Is it dance up or does it dance down? It dances up. Okay. So it dances up.
Wouldn't it just be like the opposite of your a value?
Right, because if this gets reflected,
Yeah, because a says where it turns, right?
it dances down. Which
So it
is still the
means
same.
negative 5.
Pay no attention to what I just did. So if this gets reflected, it does this.
That's cool.
how do we do that on our page? We don't have that one.
You have to use your pencil and or pen. So if I change from dancing up to dancing down, what do I become? But I'm not a negative person.
Because you're left over pi.
I am not a negative person.
She said she.
Well, yeah, you are. Oh, careful. In this case here, your h value is being moved pi over 4. So it's going to be something plus pi over 4. But our original b value here, is 4x. I need to group into that parentheses. So right now that's 4 times the x. So what do I put into the parentheses then to make sure that's just moving over 4? Because what's happens here is I can't just write plus pi over 4. Because, yeah. Well, what would be pi over 16, yeah. Because what happens is if you distribute through, now I know that this isn't really what it's asking here because it's kind of a dumb question like that. But they're really just saying, hey, can you add in a plus pi over 4? But when we get to some of the more difficult shift things that I'll give you guys here in a couple of minutes, it can get kind of messy if we're not careful with that. So for right now, that's okay, just plus pi over 4. But remember, in a minute, when we have this, yeah, because when I have this, I got to take that 4 out, and like Tyler said, that's when it becomes that over 16. That's what we'll have to worry about here in a minute. This is fine. This is fine. I'm only going to get, when we're doing when we do writing the equations, it's fine just by adding the pi over 4, because that's normal. When we go to graphing stuff, don't be surprised to see things like that, like on that number 49 where you have that b value, hiding within the parentheses. It's just one of those tricky things that we like to do.
So you just remember to like take it out.
Yeah. Okay. So speaking of, where is that? No, I accidentally closed it out.
I kind of like how like a lot of the times the like distance is like the same, like where it's either just pi or like pi.
Yeah, a lot of times they try to give you same style values so it doesn't work out to be too crazy.
Yeah, so it's like really nice. It's like if you already have done like the legwork, so like where your like halfway points are and stuff.
Yeah.
Then like you don't have to like redo it over and over again.
Here's my tree. I have stuff already.
It's kind of stuck to the thing out.
Let's graph this one. Let's graph this one.
What's theta?
Theta is x. It's just when I use the software to generate some of these things, they use theta instead of x values. That's all.
Okay.
Yes, ma'am.
Is that saying 1/2?
Yes. It says 1/2 times tangent of the quantity theta over 3 minus pi over 6, all subtract 2. So what we have to do first of all is we're still going to identify our A, B, H, and K. But in this case, our B value is hiding within the parentheses. Our A value is easy. It's 1/2. Our A value is 1/2. We know this is going to dance up. This is positive. And we know that our K value is -2. We know that without a problem. The B value, on the other hand, when we rewrite this out,
So you have to like multiply everything by.
well, what happens is, I want you to start thinking of 1/3 times what is pi over 6. So basically, you just got to multiply by the reciprocal. What's pi over 6 times 3?
1/2.
1/2. And you can easily check yourself just by distributing it back in. What's 1/3 times 1/2? 1/6. Okay. So at first it seems like it's going to be awful. So you have a b value of 1/3, which gives you a period then of pi over 1/3, which is how much? 3 pi. I'm seeing that I know I'm going to have to move my graph downward too. So I might move my original parent graph just up a little bit higher so I have less to mark off. And then I have to move, which way, left or right? I have to move right pi over 2, so I might make it a little bit longer. Yes, I forgot to write that on there, thank you. So our h is pi over 2. So that's what we start at. So my period being 3 pi, that means between my asymptotes, the distance will be 3 pi about the origin. This distance has to be 3 pi, so half of it is on the left, the other half is on the right. So what's half?
1.5.
3 pi over 2, yeah. Negative 3 pi over 2. And 0. What's half of 3 halves? What's 1/2 times 3 over 2? 3 over 4.
Wait, why is it 3 pi over 2?
Because when on tangent graphs, you've got your period sets your asymptotes.
Yeah.
Half of it is from the your y-axis over. The other half is this way.
Where are you getting that number that like makes that whole thing?
The period is it's always going to be pi divided by b.
Okay.
Pi over b. Okay. So then I have 3 pi over 4, and the other side will be negative 3 pi over 4. Okay? Your a value to start with is 1/2, which means I'm up a half and I'm down a half. And I'm dancing up. Okay? And I like to do tangent graphs because they start to get really messy if you're not careful. I like to list my ordered pairs. In fact, I like to list my ordered pairs for everything because it just makes them nicer. So I'm going to do 2 pages here because, there's never enough room. We know we have asymptotes. I have an asymptote at negative 3 pi over 2, 3 pi over 2. And I have critical points at negative 3 pi over 4, comma, negative 1/2, 0, 0, and 3 pi over 4, and 1/2. That's for my parent function. To that parent function, I have to move everything pi over 2 to the right, so I have to add pi over 2 to x, and I have to subtract 2 to the y. So it'll be x plus pi over 2, y minus 2. Okay? Not so bad? Ish, good. So what is negative 3 halves plus a half? It's negative 1, so you get negative pi for my first asymptote. Three halves plus a half is 4 halves, otherwise known as 2 pi. Is the distance between those two still 3? Or is it 3 pi? Yeah, so we're okay. All right. So now, what's negative 3/4 plus 2/4? Because that's 1/2. I'm keeping pi out of it. When I'm working with these fractions, I'm still going to have pi in my answer, but it's easier to, bless you, it's easier to walk through the fraction without saying pi. Good. So it's 3/4 plus 2/4, so you get negative pi over 4. And what's negative 1/2 minus 2.
-5.
5 halves, good. Oh no, what is 0 plus pi over 2? I cannot figure that out.
73.
You're wrong, but thank you for playing. And I do the same thing with the 3/4 and I add 2/4 on again.
Well, it's kind of nice that it's like the same.
And that's the idea. Even though this looks like crap, it does. This equation to start with the thirds and the sixes, it generally works out to be an easy fraction, whether it's a third and you might have a ninth, or a fourth and a half, or an eighth and a half. They're always going to be nothing like it's a 3 and a 4 where we have to try to get to a 12th and do that.
It looks like a lot easier if you just put like x even where beta is just to begin with.
And that's fine.
Like,
Yeah, it's just the software. The software spits out theta. As you get, anytime when you get into radians, they no matter when they're talking about in terms of pi, they always use theta. That's kind of the standard thing. And then the last one then gets you to, what is that? 1/2 would be -3/2, I believe. Okay. Not too bad. All right, well, let me show you ones that I want to work on. I have one more example, and I'll let you guys just work.
This is probably the best day that all a bunch of people are gone.
Why is that?
Because this like isn't really that like it's still kind of like you're just doing the shift graphs, right? So it sounds something completely different, you know?
Yeah, it's not totally different.
Like what the people in Ireland was like that was not like.
Yeah, well, they missed in Ireland was.
Like this is like you can kind of like understand it if you watch the video.
Hopefully.
What were you asking?
No, I want to show you another example first. So I want to flip over to the page where it says pre-calculus homework section 4.5 because where do you think this came from? Good chance.
Pre-calculus homework.
We come from April13.
It says pre-calculus.
Does everybody, hey guys, real quick, does everybody's paper have something on all 4 sides?
No.
Okay.
No, no, it's fine. I just want
Why is
to.
it on the order?
What do you think of mine?
Oh, okay. Some of them got out of sequence and the copier didn't like one of the pages. So what I want to do real quick is see if you guys can tell the difference between number 2 and number 3. What's the difference between number 2 and number 3? Very good. One's sine, one's cosine. Other than that, what are they giving you in number 3? Yeah. They're giving you a k value, a dotted line that came up off of 0, isn't it? They don't give you that on 2. So what happens here is you need to be able to identify all the parts. Let me show you how you go through this. On here it talks about amplitude period, phase shift, vertical shift. Don't worry about this whole function thing.
Cross out function.
Yeah, I'm not worried about function. Phase shift, guys. Oh, I'm sorry, function. That's the equation. Yes, that's what we're going to write. That's what the equation is. I'm thinking, is it a function, not a function? I totally forgot what I had when I was saying. Phase shift is just your horizontal. Pre-calc, we call it phase shift. We don't call it horizontal or vertical. We just call it, your H is always your phase. So they told you right off the bat that this is a cosine graph. Cosine graphs always start at an A value, 0, opposite of A, 0, and then A. Your cosine graph does that. Now, in this case, what is the value of A that the graph starts at? It starts at 3. It starts at 3, it goes to -1, it goes back to 3. But those aren't the same, are they? we have to figure out, well, how far apart are those two? They're 4 apart, which means somewhere in between, a halfway spot gives you the equal amount above and below, doesn't it? That happens at where?
So is that like an asymptote, or is it just like?
Think of that as your starting line.
Okay.
Think of that as your 0 line. Because above that, you went up to your A value. You went up 2. Below that, you went down 2. So that 1 is your K. The 1 is your K. What's that?
Why is it a negative 1? Or is it just because you're taking like the middle between the two?
Yeah, we're just doing, just saying. So your K value here is 1. If that's 1, that means then your A value is from here to here, which is how much? 2. How long did it take to get from 0 to here, to the other peak? What was the distance of the period? 2 pi. So what's your B value? 1. Since my period is 2 pi, that means your B is 1. Everybody see where we're going with this? And then from there, so that means if our period is 2 pi, it started at 0, it ended at 2 pi, is there any phase shift? No. There's no H value here. So that means that my amplitude is 2, my period is 2 pi, my phase shift is 0. Vertical shift, did we move up or down? How many? 1. And then our equation then becomes, what was it? Our A value was 2, so it's 2 cosine x plus 1.
Oh, so it's just identifying the stuff that's
Why is it a vertical shift of 1?
That, remember how that dotted line moved up from 0?
Okay, yeah.
Always think this, Jaden, is that 0 line is always going to be able to figure out the equal portions above and equal portions below for sines and
So
cosines.
these are like the shifted graphs, they're not the parent function?
Yep.
Okay.
These are your shifted graph. And then notice I did not put that, there's no H value, so there's nothing in parentheses. So one way you could have written it is 1 plus 2 cosine x, or 2 cosine x plus 1, less the parentheses, and you're fine. Does that make sense?
Yes.
Okay. Yes, ma'am. Since the period was just between 0 and 2 pi, that means it didn't move any. Here, if I start at 0 and I ended at 2 pi over 5, that means there had been some sort of, or if it was moved over or not. Most of these I don't think have a phase shift, just with message. Yeah. Now, what I'd like you guys to do on this whole worksheet is, I do not want you to do all 8 of the graphing problems. On the first page, I want you guys to do number 1, but I want you to change that to a sign problem. So you're going to do numbers 1, 2, and 4 on the first page. Change number 1 to a sign problem. Do 1, 2, and 4. Don't do anything on the back page of that one. And then you've got the 4 graphs to write, and then the 8 things on the back about just identifying parts.
Wait, what do you mean? Why do you want to assign?
So this very first problem here, I want you, for number 1, I want you to write this. Y equals 4 sine theta over 3 minus 3 pi over 4. And then I want you to do a 2
Oh, you mean the
and
first
4.
one? I thought you meant the second.
Okay, does that make sense? So you have 3 graphs to do. You have 4 write the equation out. And on the back page you have 4 identify the parts and 4 more write the equation out.
So we do the whole best.
Yeah, does that make sense?
But in 6 and just cross out like, okay, I already crossed out.
All right? You got time? Because we were working on it in second hour, and when we realized that it takes like 4 minutes to get one of the 5 minutes or so to get one graph, it's like, why'd you do 1 of each?
Am I good to go?
Yeah, if you got to go, I thought you were leaving earlier.
No, we have our bus. I asked Mr. Gunderson what time we had to leave because he has students leaving because I didn't know bus things.